Hello guys, welcome to PHY Science. In this video we'll be doing 2026 test 2 question paper for Physics 1121, which is Physics Mechanics. Question 1. State Newton's law of universal gravitation in words. First, we know that universal gravitation, it is written as F equal to G m1 multiplied by m2 all over r squared. So to define it in words, you will say every mass in the universe attracts other mass with a force which is directly proportional to the product of the masses and inversely proportional to the square distance between them. So basically, when you are defining universal gravitation, you just use the same format as Coulomb's law, which relate the force and the squared distance between two charges. 1.2.1 Define inertia. So inertia is the tendency of an object to resist any change in its state of motion. Note this, inertia is not Newton's first law. Inertia is that ability for an object to resist change. While Newton's first law, it says that an object which is moving, it will continue to move. An object at rest, it will continue to be at rest unless there is an external force which will act upon it. So there's a difference. 1.2.2 Define conservative force. A conservative force is a type of force in which the work done in moving an object between 2 points is independent of the path taken. 1.3 Block B, shown in figure 1 below, has a weight of 711 newtons. The coefficient of static friction between block B and the table is 0.25. Assume that the cord connecting block B to the node is horizontal. Determine the maximum weight of block A that will keep the system in equilibrium. So, perspicacious, what's the approach? The first thing to do, you draw your free body diagrams for the two objects. So it will be free body diagram for object B and for object A. For object B, you draw your dot representing the object, then your weight going downward, your normal force going upward, which is perpendicular to the surface, and you draw your tension to your right side pointing to the right. Then they spoke about the coefficient of static friction. So there's friction involved, and we assume that B is being pulled by A to move to the right. So your friction will go to the left. And for your object A, you will draw the dot representing the object, then the weight going downward and your tension going upward. After this, drop F net in your free body diagram. So F net for object B, it will be written as sum of all the forces along the x-axis, which will be equal to the mass multiplied by the acceleration in the x-axis. But why along the x-axis? Because we assume that object B, it is moving horizontal. So sum of all the forces along the x, it will be your tension along x minus your static friction, which is equal to your acceleration along the x-axis. But the question says that we must determine a weight which will make the system to be in equilibrium. And we know that in equilibrium, the acceleration is equal to 0. So on your right side here, m, you will multiply it with 0. Which means now your tension along the x minus your static friction is equal to 0. Then you take the negative static friction to the other side, which will give you tension along the x-axis equal to your static friction. Then again, you drop your F net in object A. So which means you will have sum of all the forces along the y-axis equal to the mass multiplied by the acceleration along the y-axis. So sum of all the forces in the y direction, you have what? Your weight, which will be positive, since we assume that when B goes to the right, A will go downward. Hence your tension will be negative, equating it with your mass multiplied by your acceleration in the y direction. And again, if object A is attached to object B, which means they share the same acceleration, which is 0. So you multiply your mass with 0, which will make your weight minus by the tension along the y to be equal to 0. Then you take tension along the y to the other side, and you will have your weight equal to your tension along the y. But you also know that the static friction, it is given by the coefficient of static friction multiplied by the normal force, where in this situation, or for object B, the normal force is equal to the weight, which is your mg. Then you substitute the coefficient of static and your weight, which will give you 177.75 newtons, which is the value of static friction. Remembering that static friction is equal to your tension along the x-axis, now it will make your tension along the x-axis to be equal to that 177.75 newtons. Having the value of tension along the x-axis and the tension along the y-axis, what do I do here, perspicacious? From now, you draw a right-angled triangle, labeling the horizontal side tx and the vertical side ty. Then your hypotenuse to be your t. Then we know that sine theta, it is given by the opposite all over the hypotenuse. Here your opposite is your ty all over t, which if you can cross multiply your ty, it will be equal to t sine theta. And again, we know that cos theta, it is given by adjacent all over hypotenuse, where your adjacent here, it is your tx all over your t. And if you cross multiply again, your tx will be equal to t cos theta. With now knowing that tx is equal to t cos theta, we can go and substitute there in object B our tx. So instead of tx, it will be t cos theta equal to 177.75. So you make t the subject of the formula. So t will be equal to 177.75 all over cos theta. And theta, you are given that it is equal to 30 degrees. So if you press your calculator, it will give you 205.25 newtons. And on object A, we already got W to be equal to Ty, which is the weight of object A. And again, we know now that Ty, it is equal to T sine theta. So instead of us writing Ty, we just substitute T sine theta. And we already calculated the value of T to be 205.25. So you will substitute and sine of your 30 degrees angle. So if you press this in your calculator, it should give you 102.625 newtons, which is the weight of object A that will keep the system in equilibrium. So let's move to the next question. 1.4. A skater is initially moving in a straight line on a horizontal ice surface at a speed of 12 meters per second. The skater then coasted to a complete stop after traveling a distance of 95 meters. Determine the coefficient of kinetic friction for 6 marks. So firstly, I will draw the scenario. Then I observe that the skater is doing work when he is moving from point A to point B. And I know that work net, it is given by a change in kinetic energy, meaning kinetic energy final minus by kinetic energy initial. And again, kinetic energy is equal to 1 over 2 mv. So I will have 1 over 2 mv square, which is final this side, minus 1 over 2 mv initial square. But before we do anything, the first thing to do, we draw the free body diagram for the skater. So we'll have a dot representing the skater, which is the object, and the weight going down, and the normal force going upward perpendicular to the surface, and the friction, since they spoke about a coefficient of kinetic friction, which will oppose the motion, meaning it will point to the left. From this, you give every force an angle, measuring it from the imaginary delta x. So the normal force, it will be 90 degrees. Your Fk, it will be 180 degrees. And your weight, it will be 270 degrees. Remembering that work done by a force is equal to that force multiplied by delta x multiplied by cos theta. And again, we know from mathematics that cos of 90 is the same as 0 and cos of 270 is the same as 0, which means there's no work done by normal force and even a work done by weight on this scenario. So we cancel them, which means our work net, it is equivalent to the work done by Fk. So you can go back to the work net formula again and substitute the work done by Fk, which will be your Fk times your delta x cos of theta. Knowing that Fk is given by the coefficient of kinetic friction multiplied by the normal force, where in this scenario the normal force is equal to the weight, which is mg. So your Fk will be equal to your Uk multiplied by your mg, which means you can go back to your work net and substitute in the space of Fk. So you will have UK mg delta x cos theta. In the statement, they said the skater then caused to complete a stop, which means our final velocity, it is equal to 0. With that information, it makes our 1/2 mvf square to be equal to 0, meaning on the right side we will just have negative 1/2 mvi square. From here you divide both sides by m, which means you will have a coefficient of kinetic energy multiplied by g dx cos theta equal to negative 1/2 vi square. Then you substitute the values. You know g is a constant, 9,8. Your change in x is 95 meter. Cos theta, your theta for Fk is 180 degrees, equal to vi. Vi you are given as 12 meters per second. So you will substitute and square it. So on your right hand side you will have negative 72. And on your left hand side you will have negative 931 UK. Then you divide both sides by negative 931 to make the coefficient of kinetic energy to be the subject of the formula, which at the end it will give you 0,0772. That's it for this video. Thank you for watching. See you on question 2. Don't forget to like and subscribe on PHY Science to be notified with more videos. Thank you.